in the exercises, we didn't get into like streets intersections that much. So put streets intersections in an address field, not include street numbers. So you just say this street and that street. So that's why we do not have the numbers. And the connectors, usually we will use characters. For example, like and, at, be consistent. If you use the symbol, then you just say use the symbol instead of just type the and. Geocoding, the flow is we put address and we will parse address and generate sound X key and find candidates in the range and the sound X key. If it's like a loop that later in computer science that we do, and if it matches, we will use the score, whether it's a best match or what. And if yes, we will have an output. If no, then we will go back to the go back here and match, no match, and output. And we either change it to match it or it's a wrong input. Okay. All right. So geocode steps that we did. So the original addresses, for example, we have a 125 East Oak Street, and we have a 15213, and address passed is 152 East Oak Street, and 15123, and abbreviation. That we will standardize it 1525 East Oak Street 15213, and the element assigned to the match keys that we will have HN 125 SN Oak S Street SDE zip code 15213. And index value calculated. We didn't get this into detail, and those are the theory for it. And soundex, we kind of sort of mention it, and even there are a lot to explain it. Soundex matches names on the basis of how they sound, if indexes match. So translate names to a 4-digit index of 1 letter and 3 numbers. First character of name remains unchanged. Adjacent letters in the name that have the same sound X key are assigned a single digit. If the end of the name is reached before filing 3 digits, use zeros to complete the code. Okay, and then if it's 4 index 1 letter and 3 numbers, first character and remain unchanged, adjacent letters assigned a single digit, and end of the name is reached before filling 3 digits, use zeros. So that here is like this. If we have the key BFPV and number 2, and then number 3, number 4, number 5, number 6, and disregard, then we have these. And the scoring, candidates use a rule-based to score source and reference match. Start with the score of 100, subtract points for each mismatch. An example for rule-based sound X indexes match but street names do not, then you minus 2 points. And street type missing in source minus 1 point, and street type do not match, then you minus 2 points. Alright, so candidate streets, for example, that we did, candidates identify 125 East Oak Street 1523, and we will look at it from to, and then street, so type, side, part, parity, direction, and street. So candidate scores and filtered that we will have from to street type, side, and part, parity, and then streets. An address match as a point. So best candidate match that you will see from here, like we have 1 to 99 to so even number on top, all numbers down button here, and you have 1 to 5 down here. Okay, so street address locator style, that we have a US range, dual ranges lines, address range, both sides of street segments, all address elements in a single field, that you have the example and finding a house on a specific side of the street, and US address single house, points that or polygons. Each feature represents an address. So an address elements in a single field that you can see from here, and finding puzzles, buildings, or address points. Okay, food source geocode on streets. That it's the assignment that we didn't spend time working on. Spatial joined to neighborhoods, and spatially joined to block problems and solutions. For example, variable in street names. That Sawmill Run Boulevard. My address is crazy as well. Route 51. Data entry errors. Fifth. This should be 5th Avenue and Sawmill Run. Place names, White House. Those are Huddersfield and Empire State Building. Those are the commonly used in same street in multiple zones. So for example, you have 100 Main Street or Washington Street. As I mentioned, you could have it in every city. Possible problems and that we have those solutions. We can clean the data, purchase. Those are just difficult if you don't have the money. Prepare a log file, we mentioned, and geocoding sources. For example, we can use Tiger File, digitized from 1 versus 100,000 scale maps, pros, free and easy to download, uniform across jurisdictional lines nationally, and street address formatting works well with the standard GIS geocoding capacities. Comms is incomplete data. Placement of address point is appropriate. Tiger line attribute table, census street center lines extracted from lines that make up census boundaries. And for example, we have Tiger File, master address file, topologically integrated geographic encoding and referencing. MAF is a complete inventory of housing units and business in the United States and its territories. Tiger is a collection of lines. NIMF produces mail-out census from ACS random samples. Tiger produces map on the ground census takers. AMF is confidential. Tiger to 09 and newer has much improved positional accuracy. So this is the Tiger file. Census zip code. That zip code tabulation areas. Approximation for census purpose do not reflect actual zip code areas and are not kept to update. So there are some local jurisdictions, parcel address points. There are some pros and cons that we didn't get a chance to talk in our tutorial, but the pros, accurate placement of residential location puzzle positional data are very often good. So you can be above or minus 5 meters or less accuracy. Cons may need to contact individual within agencies to get most up-to-date data, may not be available, or may cost a substantial amount of money. Data ends at jurisdictional boundaries. Data file tend to be very large. Local jurisdictions, street centralized pros, potential to be more up-to-date, often yearly updates, sometimes quarterly, often adequate accuracy to meet city infrastructure needs, typically above 10 or minus 10 meters or less. Cons may need to contact individuals within agencies to get most up-to-date data. Data ends at jurisdictional boundaries. And geocoding for large areas. Geographic Commons Web Service uses Tiger maps across the United States, and then Israel Street Map North American across United States and Canada uses 205 TomTom maps, more accurate than Tiger. Cool. That EsriStreetMap Premium uses here from NaviQuad and TomTom commercial street datasets, updates frequently. Online geocoding, that was the last one. That ArcGIS online organizational subscription, we uses StreetMap Premium, available for 106 countries, cost $4 per 1,000 addresses. And GeoCommons Pro, fast and easy to access, free or inexpensive. The COMS is loss of privacy, confidentiality, requires internet connection, accuracy, we don't know. So, alright, so we're gonna move to spatial analysis. That is the part 3. Spatial analysis, that we will start with approximate analysis, data mining, and network analysis. So maps sometimes require more than visualization of spatial data for users to answer questions and solve the problem. So the right data might be on the map. But analytical method offer the best answers to solutions to a problem. So here we cover for spatial analytical methods. So spatial analytical methods is buffer, service areas, facility locations, models, and clustering. The application areas include identifying legal drug, dealing with drug-free zones around schools, estimating so-called gravity model for the fraction of youth intending to use public swimming pools as a function of the distance to the nearest pools for their residents, determining which public swimming pools to keep open during a budget crisis, and determining spatial patterns of arrested person attribute for serious violent crimes. So here I introduce a new spatial data type, the network dataset, which is used for estimating travel distance or time on a street network. So ArcGIS Online provides accurate network analysis with network datasets for much of the world. Because these services require purchases, ensure that we check with everything if we have. Hopefully we don't have to deal with that for instructional purposes. And here we will use this. We will use the approximate network dataset built for Tiger Street Central Lines. Those are free to use. Okay, so buffers for approximately analysis. So let's go approximate for buffers. Here is the image. So a buffer is a polygon surrounding maps that features a feature class. So as the analysis, we will specify a buffer radius, and then the buffer tool will sweep the radius around each feature, remaining perpendicular to features to create buffers. For points, buffers are circles. For lines, they are rectangles with round endpoints, and for polygons, they are enlarged polygons with rounded vertices. Generally, we will use buffers to find what is near approximate to the feature being buffered. For schools, symbolized as points, 1,000-foot school buffers define drug-free zones. Any person convicted of dealing illicit drugs with such zones will receive a mandatory increase in jail sentence, which is intended to serve as a deterrent to selling drugs to children. We will analyze drug-free zones in here. Another example we will do is spatial analysis with buffers is food deserts, which are often defined as areas that are more than a mile from the nearest grocery store in a city. Often the person living in food deserts are poor and from minority populations, and it is straightforward to analyze affected populations using selection by location. We will select the population within buffers and then analyze selected features. For example, using ArcGIS Pro ability to summarize data. Additionally, from the Booksource webpage, we will have the opportunity to explore this topic further. Assignment 92 addresses the analog problem to food desert or urgent healthcare desert. In Pittsburgh, areas more than a mile from the nearest urgent healthcare facility